Okay, so chapter 11 is about intermolecular forces. You might have heard of intramolecular forces or inter. We're going to be focusing on inter, which means if we have compounds, we want to know how they are attracted to other compounds, not the bonds within a compound, but between them. So this is really what we're going to be focusing on. The stronger the intermolecular forces can decide what state the matter is, solid, liquid, or gas. It can determine things like physical properties, melting and boiling points, solubility, surface tension, and viscosity. So the more intermolecular forces we have, we would expect the molecules to be closer together and most likely be a solid, strongly held. The weaker the intermolecular forces, we would think that it's most likely a gas. They're not going to be as close together. So we're going to be taking a look at different intermolecular forces in chapter 11. The first intermolecular force we're going to take a look at is called lattice energy. It is going to be an ionic force. So lattice energy is determined by two different things. The first one is going to be the charge on your elements in the compound, and the second thing will be the radius of the elements in the compound. And when you want a high lattice energy, you would like a really high charge on the elements and a really small radius. So right here we can see if we're doing NaCl, the charges are 1 and 1, positive 1, negative 1. And then we would also look at the radius of sodium and the radius of chlorine and be able to figure out our lattice energy. These two factors are really going to help us decide the strongest lattice energy when we have more than one molecule. So if you take a look at the next page with examples, we have sodium fluoride, sodium chloride, sodium bromide. So you can see they all have sodium in common. So the first thing we can go ahead and take a look at is the charges, and we want absolute charges. So we have 1 and 1, 1 and 1, 1 and 1. Since the charges are the same on all of these, it doesn't really help us out determining which one has the strongest lattice energy. So next what we're going to do is take a look at the radius. We're not really concerned about sodium because it's constant. So let's take a look at the radius of fluorine, chlorine, and bromine. And the smallest radius will have the strongest lattice energy. So look right here, they gave us the radii of these three elements, but you can also use the periodic trends that we talked about earlier in this semester. Remember, the largest radius is usually around the bottom left of the periodic table. Smallest radius is usually around the top right. So our smallest radius is fluorine, therefore this will have the strongest lattice energy, strongest intermolecular force. Since it's the strongest, it's going to take a lot of heat to go ahead and melt this. So the melting point goes up, the stronger the lattice energy is. If you take a look at the next set, now our elements are a little bit different. So the first thing we'll go ahead and look at is the charges. And so we have 1, 1, 2, 1, 2, 2. And just think about it as absolute charges. The 2, 2 has the biggest charge on your two elements, therefore it's going to have the largest lattice energy and the largest melting point. Then 2, 1 is next biggest, 1, 1 least biggest.